Today I'm going to lay out some of the basics of UV mapping. Alright, so the last couple of videos that I did featured UV maps. I was working with Blender and Nomad and Procreate, and a lot of the trouble that I had in some of the original videos was that UV mapping didn't happen automatically, although some of that's been fixed in Nomad, so now we can go forward and paint things like I did before. But I did get some questions from people where they really have a hard time understanding what a UV map is. And there's a couple of reasons for that. One of the reasons is, most of the time, we don't have to think about what UV maps are. We just have to use them and know that they're there. The other thing is, UV doesn't really make any sense. Where is that coming from? So to get started, I just want to lay out the idea that if we think about X, Y, and Z, and how that relates to space, U and V, and sort of secretly W, are the same thing, but for surfaces, textures that are going to be applied to a geometry. So I'll give you a practical example. Here I have my geometry. It's a basic cube, right? And I have a texture. My texture has what we might think of as an X coordinate and a Y coordinate, but in texture language, we're going to keep it as U and V, right? So if I take this texture and I apply it to my geometry, I now have a cube with letters on it, right? Front, back, up, down, right, left. But if you think about it, this cube still exists in X, Y, and Z space. But if you look at our UVs, in the front, maybe U goes this way and V goes this way. It goes up. But by the time you get to the back of the shape, V goes down. So since UV directions get all crazy and go in all sorts of different directions, it's helpful to keep them distinct from global or object-based X, Y coordinates. Now let's take a look at this in Blender. So for the first time, I think in a long time, I'm going to actually use the Blender cube. In order to work with our UVs, we're going to use the UV editor. And in order to see which faces appear as UVs, we need to switch to edit mode. And now you can see the same cross shape that I had for my physical texture. If I click on one of the faces in real space, you'll see which UV texture is associated with it. So our next step is to open a texture. I happen to have my texture ready to go. I'm going to zoom out for a moment. And now you can see that the UV squares line up with each face. In order to see them happen live, we need to do two things. We need to turn on texture view or rendered view, and we need to create a shader that actually uses the image. So let's bring up our shader editor, and we're going to apply an image texture to our base color. In Blender, once you've loaded the image, it exists as part of the library. So you can just select it from the list and then connect the color. And now it's real. That's all well and good. And by default, a Blender cube comes with that cross UV map already laid out. But you don't have to keep your UVs in the same place. You can move them around. So let's take a look and see what happens if my texture has some of my graphics in different spaces. I'm going to load another version of my texture, one where I move my letters all over the place. I'm going to change the image texture in my material to the new map. And you'll see that now things are kind of screwed up, right? And it's because my UVs don't match anymore. This one's only partially on the B, and if I choose to move it, I can click it and grab with G. I can place it where it's supposed to go. As I move it, you can see it's almost like a little magnifying glass that shows whatever's on the texture in that space. So I'm going to put it on the right. Now I'm going to click on this one, select it in my UV map, and click G to grab. And I'll move it towards back. But you'll notice that it's been rotated. we can also rotate our UVs and the texture will rotate in the opposite direction. I'll use 90 degrees and now it matches. I'll move this one over and I'll work on this one. This one belongs on the left side. And this can be my front. Front is upside down, so I'm going to use R to rotate and then 180 to make it right side up. So you can see that UVs also are concerned with direction. Even though it looks like a square, not all four sides are equal because they're pointing in different directions. Now I've managed to somewhat recreate my original graphic by moving my UVs all over the place. So you can see what I just did is similar to taking a particular face out of my texture and I put it on one particular surface, right? And I could do that with the other 5 of these, but this physical model has limitations, right? Because we're working with computers, we get to do things that are kind of like magic. Let's try doing the same thing again, but with shapes that don't fit each surface. All right, this time I'm gonna load another texture, but I did some crazy stuff to my letters. And I'm also gonna update which texture I wanna use in my shader. And there we go. Now things look even crazier than before. So in order to fix it, I'm gonna click a face and then I'm gonna click that face's UV and I'm gonna move it to where I want it to be. I'll start with my front, which is at a weird angle. So I'm gonna use R to rotate. And then what I'm gonna do is move part of my UV by edge. So instead of using the whole face, I'm just gonna click an edge. Very similar to how you can work with things in 3D. I'll use G to grab, and I'll just move each one to where it's gonna belong. And you'll notice that because I've distorted my UV to match the distortion of my texture, somehow it all works out, even though the pixels look like they're at a weird angle, right? Okay, next I'm gonna take the top one. This one's easy because that's the only one that hasn't been changed. So that's more or less like it was before. And I'll work on the left side. With this one, I can still use my edge selection and I can just skew one of the sides over and it will correct the distortion. Basically, if both of them are distorted in the same way, they'll come out looking normal. I can also scale. This R is too small, so if I make the UV smaller, it makes the texture bigger. So basically everything that you do has the reverse effect on the actual geometry. The same thing works for D, except this time I'm gonna make the UV bigger, which makes the texture smaller so that it fits. Put it in place there. And this last one, I'm gonna do for the B. Instead of using an edge, I'm actually gonna use point selection. And point selection is gonna let me move each part of my UV's polygon. If I just take some time and put the pieces in the right place, but I've run into trouble. Now my B is kind of sideways, which means my points all have to be moved to a different location. So I'll kind of go counterclockwise here, see what happens. Boy, that B is looking really strange. All right, so I probably should have gone clockwise. I'm gonna switch these over, and now my B is still not set up correctly. All right, let's try counterclockwise one more time. I'm sure I could have done that much more easily if I had gone clockwise from the start. And there, I've gotten it. And you'll notice that there's some weird distortion that's happening. It's because even though this is a square, it's made up of 2 triangles, and you can almost see the crease right down the middle, where the computer kind of has to figure out just how you want things to be distributed. But more or less what we started with, just a lot less efficient. So of course, UV mapping, like every subsection of 3D graphics, has sort of a beginner, middle, and advanced level, and you can learn all sorts of really important techniques to avoid artifacts or make things more efficient. But when you're thinking about UVs, in the most basic sense, I hope that this will make things more clear going forward. So what do you think? I hope this makes UVs a little bit less mystifying and that you'll go and play with some in Blender and make your own crazy UV experiments to see what happens. And until next time, take care.